Welcome back in our today's class. My name is Victor Odigoma here, and in this class we are going to be looking at another problem that has to do with chord and arc of a circle. Of course, this is a subway, it's a tunnel. Okay, it is made up of an arc and a chord. Okay, so the question demands us to calculate the perimeter of this subway, the perimeter of this like a sort of a railway, subway tunnel. All right. So in the previous class, we have been able to look at questions that come from a chord and chord properties, and then circle. And we've looked at, there are questions we've handled that has to do with parallel chords on opposite sides of the circle, parallel chords on the same sides of the circle, like in the just concluded last class. And some other problems we will also looked at, that has to do with chord of a circle. Why I'm mentioning these things is that you need to check out on those classes so that you can be able to follow us in what you are doing in the moment. Because understanding those classes will also help you to be able to follow what we are doing in the moment. Okay, please check out on those classes. So in this particular question, we are asked to calculate the perimeter of this subway. Now, you know rightly that perimeter is just distance around an object. Distance around an object. So whenever we are talking about perimeter of a thing like this, we'll be talking about the perimeter of this major arc. This arc A, Q, C. And the length ABC, which is the length of that chord there. Okay. Now we will take it one at a time. Now there's another thing one need to know, because anytime you want to approach a question, there are some things you need to capture in that question that will help you to be able to know what to do in that question. If you look at this diagram, you will be seeing that they told us that AB is equals to BC and equals to BO, meaning that this triangle here is isosceles and this one is also isosceles. Now, if this AB is equals to BO, and this angle here is 90 degrees, we quickly resolve the implication that base angles of isosceles triangles are equal, meaning here is 45 and here is 45. The same way, here is 90, here is 45, here is 45. So I'm trusting God you now know that if here is 45, here is 45, obviously this angle here is 90 degrees. So that information is going to help us in resolving this question. So we are going to say that solution. We are going to say since AB equals to BO, okay, and this is happening in triangle ABO and also in triangle BOC, that BC is equals to BO, okay, right? Then means we can conclude that this angle AOC is 90 degrees because it is made up of 45 degrees here and here 45 degrees. Since this angle here and this angle here will be equal and base angles of isosceles triangles are equal. Okay, so with that notion, with that knowledge, we can be able to check this calculation, letting the length of the arc A, Q, C, okay, that length arc AQC, calculating that, we will need to know the angle over here. The angle over here. Okay? So angle at that is reflex. The reflex angle AOC, okay, will be 360 minus 90 degrees, which is 270 degrees. So that is what we are going to use. So now from theta, the formula theta over 360 times 2 pi r, which is used in calculating the length of an arc. Okay, length of an arc. So theta here will be 270 degrees because we are calculating the major arc. I am sure we are following the explanation stage by stage, one after the other. First of all, I was able to tell us that this is an isosceles triangle, and for the fact that here is 90 degrees, the base angles must be equal because it's an isosceles triangle, and for the base angle to be equal, you have 90 out. Sum of angles in a triangle is 180 degrees. If you remove 90, it will remain 90. You share that 90 into 2, here will be 45, and here will be 45. You go over to the other also in the triangle, the second triangle. If here is 90, you have 90 left, 90 degrees left. Here will be 45, here will be 45, completing sum of angles in a triangle being 180 degrees. I'm sure that explanation is okay. Now here, you see that if here is 45, here is 45, that will make that 90 degrees in angle AOC. AOC. Now, but this arc we are trying to calculate is on the other side. The angle needed to do the calculation is on the other side, that reflex angle there. So that's why I said calculating the length of the arc AQC, angle at the ref, that is on the other side, ref AOC, reflex angle there is 360 minus 90, that will give us 270. That is what I am going to use here over 360. So theta is 270 over 360 times 2 times pi is 22 over 7 times radius, which is they gave us the radius to be 2 cm, 2 times 2. Okay, so we can take away this and take away this. 3 here or 9, I think 9 here should be 3. 9 into 27, 9 into 36 is 4, and then this 4 will take away this 2 and this 2. I'm sure you saw that. So obviously what is left is 3 times 22 over 7. 3 times 22 over 7. And in the calculation I have here, that will be 66 over 7. 66 over 7, which is 9.43. 9.43 cm. Is it in centimeters? Yeah, centimeters. So we will keep that aside. Then the next thing we need to calculate is the length of the chord ABC. Okay, we need to calculate the length of that chord. So we will say also the length of chord ABC, of chord, let me say chord AC. Okay, AC, we are going to have that AC is equals to 2r sine theta over 2. Of course, this is the formula we are going to use to do the calculation. This formula is used to calculate the length of the chord when the angle at the center is given. You use it to calculate the length of that chord. Okay, you can also calculate length of the chord, a chord, by Pythagoras theorem, or even using SOHCAHTOA. Okay, so what we have here is the length of this chord, okay, is equals to 2 times 2 times the angle at the center there is sine 90/2. The angle at the center there is 90 degrees. So here we have 4 times sine 45 degrees. So this is 4 times sine 45 degrees is √2/2. So we have √2/2. This take away this, take away this. We have 2√2. And 2√2 is 2.83. 2.83 cm. Therefore, the perimeter of the subway is 2 2.83 plus what we calculated previously, 9.43. Okay, so that distance like this and like this of the subway is equals to 12.3 cm. So I'm trusting God this explanation will help us to do some other calculations that are related to this, because this is not the end of it. Every day we keep on discovering questions, we keep on discovering problems. So I'm sure this explanation I gave in describing the information that is made available in this place is okay for us, and the calculation, following the calculation, was able to help us to capture it, and then we were able to arrive here, and then we're able to draw a conclusion that the perimeter of this subway, distance around the subway, is 12.3. So in case if you encounter any other similar question like this, I trust God that this is going to help you to be able to resolve it. But otherwise, if you have a questions, if you have confusions that you need to clarify, you can drop a comment in the comment section. We'll follow it up and see how we can be able to partner with you and assist you in succeeding in whatever thing you are doing outside there that has to do with calculation or mathematics. All right. So thank you so much for being here. Please encourage us by subscribing to the channel. Okay, and then also share the video to someone out there. All right, and yeah, because someone out there might be in need of this information. So good thing you do is to share to someone out there, and then clicking on the subscription button and the notification button. As you do that, you are encouraging us to grow as we are making more impact in the society. Thank you so much for being there.